Hello students. Today we are going to discuss about more about normals. So in this case what happens, let parabola is y square is equal to 4x, and this is the parabola, and suppose we are having a point P and another point Q, and we are drawing a normal over Q and which is intersecting Q on the parabola itself. Say for this point is a t1 square comma 2a t1, and this is a t2 square comma 2a t2. So we have to find out this is normal. So equation of normal at point P and intersects the parabola again at Q. Then find relation between T1 and T2. So we know that equation of normal at P is y plus tx is equal to 280 plus 80 cube. So it is 1, 1, 1. Now it is passing to point Q, so point Q will satisfy this. This is 2a t2 plus a t1 t2 square equals to 2a t1 plus a t1 cube. So this is 2a t2 minus 2a t1 equals to a t1 cube minus a t1 t2 square. So we are taking common 2 t2 minus 2a, and this is a t1 we are taking common, so this is t1 square minus t2 square. A and a gets cancelled, so twice of minus twice of t1 minus t2, and this is t1 minus t2 and t1 plus t2. So this gets cancelled. So t1 plus t2 is equal to minus 2. So t1 plus t2 is equal to minus 2 upon t1. So t2 is minus t1 minus 2 t1. So this is the relationship between t1 and t2. You must have to learn it. Otherwise, you have to use it directly. Otherwise, you have to derive and then you have to use it. So you should keep it in mind to solve it. Now we are moving to next part of it. Suppose there is a point A and another point B, and one normal is drawn at A and another normal is drawn at B, and they are intersecting at C, at1 square comma 2 at1, and this is a t2 square comma 2a t2, and this is a t3 square comma 2a t3. So normals at AB intersect the parabola y square is equal to 4ax at C. Then prove that T1 T2 is equal to 2. So what we have seen that T3 will be equal to minus of T1 minus 2 upon T1, question number 1, and this T3 will also be equal to minus T2 minus 2 upon T2. So these two will be equal. So minus of T1 plus 2 upon T1 is minus of T2 plus 2 upon T2. Minus minus gets cancelled. So T1 minus T2 is 2 upon T2 minus 2 upon T1. So T1 minus T2, we are taking common T1 minus T2 upon T1 T2. So this gets cancelled. So T1 T2 is equal to. So this is the required relationship. So you must have to learn this relationship while solving the problems. Now we are moving to next type of question. Suppose this is the parabola and there is a point A and another point. We have drawn a normal at A and at B, which is intersecting the parabola at point C. Let this point is a t1 square comma 2a t1 and point B is a t2 square comma 2a t2. Now we have to find out the locus of midpoint. Find locus of midpoint P on line A. So for this, we are considering it as a h comma k. Since P is a midpoint, so we know that h will be equal to at1 square plus at2 square by 2. So this is 2h upon a equals to t1 square plus t2 square, equation number 1. Similarly, k will be equal to 2a t1 plus 2a t2 upon 2. So k is equal to a times t1 plus t2. So k upon a is equal to t1 plus t2. Now, since a normal at A and normal at B intersecting at a point C, then we know that T1 T2 is equal to 2, as we and discussed also. So this is equation number 3. Now we are using this formula T1 plus T2 whole square equals to T1 square plus T2 square plus 2T1 T2. So T1 plus T2 we can put as this is x square upon a square and this is 2h upon a and this is a 4. So k square is equal to 2ah plus 4a square. So k square equals to 2a, we are taking common h plus 2. So taking locus y square is equal to 2a x plus 2a. So this is the required locus of the point P. So with the help of this we can solve. Now we are moving to next uh, intersection of intersection point of normals. Intersection points of two normals drawn from 2 points a t1 square comma 2a t1 and b a t2 square comma 2a t2 to parabola y square is equal to 4x. So what we can see that this point is a and this point is b and this point is b. They are intersecting at p. a t1 square comma 2a t1 and this is a t2 square comma 2a t2. So equation of normal at A is a y plus t1x 2a t1 plus a t1. So equation number 1. And second one is y plus t2x plus 2a t2 plus a t2 cube, equation number 2. Now we are subtracting. So it is a t1 minus t2x and this 2a we are taking common, t1 minus t2 plus a we are taking common, t1 minus t2, t1 square plus t2 square plus t1 t2, t1 minus t2 gets cancelled. So x is equal to how much? 2a plus a times t1 square plus t2 square plus t1 t2. Now for finding out the value of y, we'll put value of x in one of the equation. For finding out the value of this, we'll put the value of x in one of the equation. So y plus t1, and this is 2a, a t1 square plus t2 square plus t1 t2, and this is equal to 2a t1 plus a t1 cube. So y plus 2a t1 plus a t1 cube plus a t1 t2 square plus a t1 square t2. This is equal to 2a t1 plus a t1. So a t1 cube gets cancelled, 2a t1 cube is also cancelled. So y plus a times t1 t2. You can see that t1 plus t2 is equal to 0. So y is minus of a t1 t2 into t1 plus t2. So coordinate of p is basically 2a plus a t1 square plus t2 square plus t1 t2 comma minus a t1 t2 t1 plus t2. So this is the point where which we have to remember. Otherwise, you have to calculate from scratch. So that's all in this video, and rest we'll discuss in the next class.